Connecting a portable dimmer rack to an installed grid requires careful attention to detail to ensure safety and proper operation. Let's explore the special requirements for such an installation. Firstly, grounding is paramount. The grounding conductors from both the grid feed and the portable dimmer rack must connect to the same ground point inside the junction box, or J-box. Ensure that these ground conductors are adequately sized according to the National Electrical Code, or NEC. Secondly, consider neutral bonding. If the system utilizes a three-phase, four-wire distribution, the neutral conductor from the grid feed and the portable dimmer rack must be bonded together at the J-box. This ensures a common reference point for the neutral. Thirdly, regarding circuit protection, while the 15 amps breakers and the dimmers offer overcurrent protection for individual circuits, the entire system needs protection from a main circuit breaker or fuse. Its rating should correspond to the total load of the portable dimmer rack. Cable and connectors are also crucial. The SER cable used for the hanging Edison connectors must have a voltage and current rating suitable for the portable dimmer rack. Ensure the cable length allows easy access to the dimmer racks. Safety measures are non-negotiable. Verify all connections are secure and properly insulated. Always use appropriate personal protective equipment, or PPE, when working with electrical equipment. Most importantly, to energize the system before making any connections or modifications. Here are some additional suggestions to enhance the installation. Consider permanently mounting the J-box to the grid. This provides a more stable and reliable connection point for the portable dimmer rack. Labeling is important for safety and clarity. Clearly mark the J-box to indicate its purpose and the origin of the grid feed. Regular inspection and maintenance are key. Routinely check the installation for loose connections, damaged cables, or other potential hazards. Conduct maintenance as needed to keep the system safe and reliable. The specific requirements for grounding involve ensuring a low impedance path to ground. This path allows fault currents to flow safely back to the source, tripping the circuit breaker and preventing electrical shock hazards. According to the NEC, the size of the grounding conductor is determined by the size of the ungrounded conductors. Refer to NEC Table 250.122 for proper sizing. The equipment grounding conductor should be green or green with yellow stripes. Neutral bonding is critical in a three-phase, four-wire system to provide a return path for unbalanced loads. If the neutral is not properly bonded, voltage imbalances can occur, potentially damaging equipment. The neutral conductor should be white or gray. Circuit breakers and fuses protect against overcurrent conditions such as short circuits and overloads. The 15 amps breakers and the dimmers protect the individual circuits, while the main breaker protects the entire dimmer rack. The main breaker should be sized appropriately based on the dimmer rack's total load, taking into account any diversity factors. Cable selection is essential for ensuring the safe and reliable transmission of power. SER cable is a flexible cord that is commonly used for portable applications. The cable must be rated for the voltage and current requirements of the dimmer rack. The ampacity of the cable is determined by its size and insulation type. Refer to NEC Table 400.5 for ampacity ratings. Edison connectors are standard 15 amps, 125 volts connectors used for connecting electrical equipment. Ensure the connectors are in good condition and properly installed. Tight connections prevent overheating and potential fire hazards. Loose connections can create resistance, which generates heat. Over time, this heat can damage the insulation and lead to a short circuit. Proper insulation prevents electrical shock hazards. Ensure all connections are covered with an insulating material, such as electrical tape or heat shrink tubing. Personal protective equipment, or PPE, is essential for protecting workers from electrical hazards. PPE includes items such as safety glasses, insulated gloves, and arc-rated clothing. De-energizing the system before making any connections or modifications is crucial for preventing electrical shock. Always verify that the power is off using a voltage tester before working on any electrical equipment. Permanently mounting the J-box to the grid provides a stable and secure connection point. This helps to prevent accidental disconnections or damage to the cables and connectors. Labeling the J box clearly identifies its purpose and the source of the grid feed. This can help to prevent confusion and ensure that the correct connections are made. Regular inspection and maintenance can help to identify potential problems before they become serious. Check for loose connections, damaged cables, and other hazards. Repair or replace any damaged components as needed. The NEC provides detailed requirements for electrical installations. Familiarize yourself with the relevant sections of the NEC to ensure that the installation is in compliance with all applicable codes and standards. It is also important to consider the specific requirements of the local jurisdiction. Local codes may be more stringent than the NEC. Consulting with a qualified electrician is recommended. A qualified electrician can help to ensure that the installation is safe and compliant with all applicable codes and standards. They can also provide guidance on selecting the appropriate equipment and materials. Remember to always prioritize safety when working with electricity. Follow all safety precautions and procedures to prevent electrical shock and other hazards. In summary, connecting a portable dimmer rack to an installed grid involves several key considerations. These include proper grounding, neutral bonding, circuit protection, cable and connector selection, and safety measures. By following these guidelines and consulting with a qualified electrician, you can ensure a safe and reliable installation. Grounding ensures a safe path for fault currents, preventing electrical shock. Neutral bonding is crucial for three-phase systems to maintain voltage balance. Circuit breakers and fuses protect against overcurrents, preventing damage to equipment and potential fires. Cable selection is vital for ensuring the safe and reliable transmission of power. Safety measures, including PPE and energizing the system, are paramount for preventing electrical hazards. Additional suggestions, such as permanent mounting, labeling, and regular inspection, enhance the overall safety and reliability of the installation. The grounding system should comply with NEC Article 250. This article provides detailed requirements for grounding and bonding electrical systems. The impedance of the grounding path should be low enough to allow sufficient current flow to trip the overcurrent protective device in the event of a fault. Neutral bonding should be performed in accordance with NEC Section 250.24. This section specifies the requirements for bonding the neutral conductor to the grounding electrode system. Circuit breakers and fuses should be sized and selected in accordance with the NEC Article 240. This article provides requirements for overcurrent protection. Cable selection should be based on the ampacity and voltage rating of the cable. The ampacity of the cable should be sufficient to carry the maximum load current. The voltage rating of the cable should be equal to or greater than the system voltage. Safety measures should include the use of appropriate PPE, such as safety glasses, insulated gloves, and arc-rated clothing. The system should be de-energized before making any connections or modifications. Lockout/tagout procedures should be followed to ensure that the system remains de-energized while work is being performed. Permanent mounting of the J-box provides a stable and secure connection point, preventing accidental disconnections or damage. Labeling the J-box clearly identifies its purpose and the source of the grid feed, preventing confusion and ensuring correct connections. Regular inspection and maintenance help identify potential problems before they become serious, ensuring continued safety and reliability. Inspect for loose connections, damaged cables, and other hazards. Repair or replace any damaged components as needed. Adhering to the NEC and local codes is essential for ensuring a safe and compliant installation. Consulting with a qualified electrician provides expertise and guidance, ensuring the installation meets all applicable standards. Always prioritize safety when working with electricity. Follow all safety precautions and procedures to prevent electrical shock and other hazards. Consider the load calculations for the dimmer rack. Determine the total current draw of all the dimmers and any other equipment connected to the rack. This will help you select the appropriate size circuit breaker and wiring. Also consider voltage drop. Voltage drop occurs when the voltage at the end of a conductor is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction. To minimize voltage drop, use larger conductors or shorten the length of the conductors. Ground fault circuit interrupters, or GFCIs, protect against electrical shock by detecting ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person. GFCIs should be installed in areas where there is a risk of electrical shock, such as wet locations. Arc fault circuit interrupters, or RSIs, protect against electrical fires by detecting arc faults. An arc fault is an unintentional electrical discharge that can occur when insulation is damaged or when connections are loose. RSIs should be installed in branch circuits that supply bedrooms and other areas where people sleep. Surge protection protects against voltage surges, which are sudden increases in voltage that can damage electronic equipment. Surge protection devices, or SPDs, should be installed at the main electrical panel and at sensitive electronic equipment. Ensure compliance with the Americans with Disabilities Act, or ADA. The ADA requires that electrical equipment be accessible to people with disabilities. This includes ensuring that the equipment is located within reach range and that it is easy to operate. Provide adequate ventilation for the dimmer rack. Dimmer racks generate heat, so it is important to provide adequate ventilation to prevent overheating. The ventilation system should be designed to remove heat from the rack and dissipate it into the surrounding environment. Consider the noise level of the dimmer rack. Dimmer racks can generate noise, so it is important to consider the noise level when selecting a location for the rack. The rack should be located in an area where the noise will not be disruptive. Inspect the equipment regularly. Regularly inspect the dimmer rack and related equipment for signs of wear and tear. Replace any damaged or worn parts immediately. Maintain records of all inspections and maintenance. Keep detailed records of all inspections and maintenance performed on the dimmer rack and related equipment. This will help you track the performance of the equipment and identify any potential problems. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Never work on electrical equipment while it is energized. Always energize the equipment before working on it. Follow all safety precautions and procedures. By following these guidelines, you can help ensure that your portable dimmer rack is connected to the installed grid safely and reliably.